One to Robot Builders Night Virtual for 28th of May 2024. Tonight we'll have the usual agenda of people with topics to talk about, and then open mic preceded by a bit of a DPRG few DPRG update points. So this weekend, very exciting. We've got Roborama on Saturday. We're actually going to do a simul contest. So we'll for the first time we'll have the remote location up in Ottawa, Canada, with the DPRG North team there, and we're going to interleave robot runs. We'll see how it works. You know, this is an experiment, and if it collapses, then we'll figure something else, figure out something different. But for right now, the plan is that we'll start with the contests that are being run in both locations, and whenever anyone's ready in either location, we'll run whoever's ready, and we'll have a video link, video conference like the video conference tonight, connecting the two sites along with anyone else who's attending remotely. Video for remote attendees will begin around 12:45. So for those of you planning to attend locally, pizza. Actually, let me just share the. So pizza is at noon, and before that, at 11 o'clock, we will have we'll be checking in robots, and there may be an opportunity to do test runs of the robots. So let me just share that real quick. Well, okay, maybe I won't. Anyway, look at the DPRG website for the competitions, for the Roborama 2024 competition, and you'll see the full schedule. But basically, we're going to start setup at 9, and at 11 we'll be looking at robots, and anyone who wants to practice may do so. Noon will be pizza, and then we'll start the video call at 12:45, and 1 o'clock we'll start the competitions in both locations.
Just a point of clarification, Paul, our northern location is actually in Hamilton rather than Ottawa.
Oh, I apologize for my ignorance, Tom. Thank you.
No worries. Technically, it's in Stony Creek, a suburb of Hamilton. So.
Okay. Are they? Okay, good. Hamilton. What state of Canada is that in?
Ontario.
Ontario. Okay.
Halfway between Toronto and Niagara Falls.
All right. Monthly meeting coverage. I asked last meeting for some help providing coverage, and Pat very graciously stepped up, as did Mike. And thank you, guys. I've got Pat all set up to where he can admit people and begin recording, and Mike, I'd like to do that with you as well. And we've got a process that we're using for the first time tonight to record using Google Workspace, which we subscribed a DPRG account to. So you'll see in the top something new in the top left of your screen. I think you'll see that a red recording button indicating that we're recording this call. So this is a much more robust scheme for recording calls and something much more able to be distributed, to be shared, and have other people help out on the call and do recording if the usual team is not available. We did have a change in dates. Come on, why aren't you advancing? Because I'm not clicking the right screen. So June 22nd is the next meeting after Roborama, and that, very excited about that. Bob Cook from up north with you guys is going to be talking about his latest advancements in training in AI for cone finding. This will be an all virtual meeting, so there won't be a physical meeting, an in-person meeting at the Dallas Makerspace. July 26th got opened up because we moved Scott Gibson to August 23rd. So we'll let you know what happens with July 26th. Let's see. Anything else DPRG related that I didn't mention? If not, we'll go to the list. And Ray.
Yep. Okay. One of the things I got working, was using, this is the NESP32, the display and touchscreen, passive touchscreen, and I put it in a 3D enclosure, printed it out. Anyway, so it's not that big of a deal, but now I can actually use this for telemetry. So I plug this into my laptop and open up either an Arduino window or project, and I can have the ESP on the robot, communicate to this, and then it prints out, does just serial prints and print lines for back to an Arduino window, basically, and serial monitor window. So that's a way. That is not the most convenient way, because you can't copy the stuff in the serial monitor and maybe, put it in Excel and, quickly check your calculations or something, or your logic. But it was convenient, and, it's certainly not a new thing. I don't know if Doug's on here tonight. I thought I saw him. Yeah, there he is. Doug and I both used Wixels, which are, it's another RF link that you can plug one into your serial port in your or connect the serial port in whatever processor you're using to it, and then connect the other one through a USB cable to your laptop and do essentially the same thing. So it was really helpful with the debugging, because I'm trying to get this thing working with the lens that I'm using to try to find the two markers at the end of one goal. And this thing is spinning around and moving pretty quickly, and it was pretty convenient to have it. The wireless serial, Wixel. I think it's a Polulu part. I don't know if you've ever seen those, but yeah, you use a pair of them. One is a transmitter, the other is a receiver. If that's what you're talking about. These are the other things are. It's a WTSC01 board. Oops. I can't see the thing there. I always end up in the bottom square, so if anything comes up, it blocks off my window. Anyway, so it's a pretty good size display. It's 480 by 320. It's capacitive touch. And it, so you can display whatever parameters you want to display on the screen, and you can also use it for debugging. I haven't used it, but one of the other, MOBA X term. I don't know if anybody uses that. But in that, you can actually copy what's listed in, like a serial monitor and move that to different files. So if you wanted to do, upload it to Excel and do checks on it. So, but it's the first time, doing it with these, and it was pretty convenient. So anyway.
So Ray, can I just make sure I understand what this box does, how it fits in at a sort of block level to a system? So it accepts serial data from a robot, is that right?
Well, it uses ESP now. So I've got an ESP32 on the robot. It transmits to this unit. Oh yeah, Doug got the Wixel thing up there. Thank you, Doug. Or you could transmit it to any other ESP32 or, well, I just use the ESP32s. So this gets plugged into my laptop, and I can either open up the serial monitor in an Arduino IDE window, or use like MOBA X term, or, one of those that I can actually copy the contents from if I want to put that into Excel to check calculations or logic. So
the robot is running ESP now and publishing some serial data to ESP, or serial packets, if you will.
Right.
To ESP now, and then this box is plugged into your laptop and looks like a serial port to the Arduino IDE, and pastes and prints whatever it gets over ESP now. Wow,
yes,
that's really clever.
Yeah, well, not that clever. I'm sure, Wixels have been out for, I don't know how many years, but it was the first time I actually did it with one of those, with the the ESP32. So, and like I said, it was very convenient because the thing's running around pretty fast, and it's impossible to get, just look at a display that's on the robot to write all that down, because it's
right.
It's a pretty tight loop.
And what's a Wixel, and how does it fit into the scheme?
Oh, Wixels are an alternative to the ESP32. They were, I don't remember the processor that it was based on, but it was another one that had wireless capability. So you could do a wireless link, say, from the robot to your laptop. So same sort of thing that I'm doing with the ESP32s and ESP Now. You could use a pair of
Wixel for it. So it was a previous solution that did a similar thing.
Yeah, I don't know how long the Wixels have been out. Quite some time, at least 5 years, probably maybe more than that. I'm not certain when they first got introduced, but
I think of it as a Bluetooth alternative, right? I mean, a lot of people use Bluetooth for like a wireless serial link, right? It's
right.
Kind of was competing with that. I'm not sure what its value proposition really was, but
with these,
yeah, the Wixel compared to a Bluetooth serial link.
Yeah, I think, God, Wixels may have been around. Well, I don't know. Bluetooth's been around for a long time too. But yeah, I'm not certain when they came out, but they were reasonably priced, and they would transmit over a pretty good distance. But since I have an ESP32 on my robot, and it supports ESP Now, it's pretty convenient to use. I mean,
yeah,
Yeah. So,
And a few weeks back, I remember some people describing that they thought they might be losing packets. Have you found that have you observed that, or?
no, it seems pretty good. I haven't counted up all the bytes that typically with ESP now, you set up a structure, and it has to be less than 250 bytes.
Right.
I was sending them like 20 times a second, and it takes like, I think it was either 100 or maybe a little bit more, somewhere between 200 and 100 microseconds to transmit, the packet, because I could, going into the loop and going, I did like a scope loop where you set a pin high when you go in and set it low when you go out. And, I could actually measure how long it took to do, to execute those statements. And so, you're talking about 20 times a second, 50 milliseconds versus maybe at most 200 microseconds of the total
percentage.
Yeah, loop time of
Wow, that's pretty interesting data.
The default speed on ESP now is a megabit. So
default speed. Oh, for ESP now, you mean?
Yeah.
Oh, okay. Yeah. Okay, so megabit. Yeah, I guess you can figure out what that time would be. I'm assuming there's some overhead that goes with the packets, so it may be, more than that. I don't think my packets are that big. I mean, like I said, I haven't figured out how many bytes they are, but I know it's less than 250. So,
well, I mean, in 100 microseconds, you can send basically 100 bits, which would be about 10 bytes.
Oh, okay. Yeah, it seemed like it was more than that.
20. I mean, you can also change the speed, so you might be running at 2 or 4 megabits or whatever. That's just the default speed.
Oh, okay. Yeah, I'd have to look. I'm not certain what speed it's running at.
That's curious, John, about the ESP now having a quoted bit rate.
Well, it's based on Wi-Fi, right? I mean, effectively, it's using the same stack as Wi-Fi uses, just not requiring an access point. So
exactly, but Wi-Fi transmits at it can transmit at 100 megabits per second.
Well,
only
there's not very many Wi-Fi systems that'll do 100 megabits. I mean, maybe they're brand new phones and stuff, but I mean, 20 megabits is a reasonable thing for Wi-Fi, and you can make ESP now go a lot faster, but it defaults to a megabit because most people are not sending a lot of data. It's really it's peer-to-peer mesh networking. People don't, it gets complicated.
But if you specify it as having a bit rate, does that mean it's throttled to that?
I don't know. I mean, it's like a UART, right? You just say what your baud rate you want to use. When I communicate using a serial UART, I normally run it at a megabit unless I'm talking to something like that requires a specific baud rate, like 150, 200. But when I'm doing my own like inter-processor communications over a serial UART, I normally talk at a megabit too, because it's just a convenient speed.
Yeah, but when you have a UART, you have a physical bits getting clocked out on the wire at a certain rate. That is the rate they go at. Whereas for network communications, it really is much more a function of protocol overhead, and the wire speed is typically a lot faster. So it just seemed, I was just surprised to hear you quoted as spec'd at a certain rate.
Yeah, well, I don't know why that is, but that's what the docs say. So
interesting. Huh.
Yeah, I think I was sending 3 floats and 4 ints, so integers, so in the packet. So I'm probably
yeah,
well
so
below.
that's around 20. That's around 20 bytes. So if you were running 20 bytes is around 200 bits, including a bit of overhead. So that would, at a megabit, that would take 200 microseconds. So
Yeah. Anyway, seemed plenty fast enough, and like I said, my packets aren't that big. I've never had at least that I could tell,
Well,
an issue with dropped
and
packets or anything.
and the other thing that you have to remember is, that's how long it takes you to give it to ESP now. That's not necessarily how long it takes for it to transmit it to the other machine. If it's probably got a 250 byte buffer on the transmit side that you're just shoving bytes into that buffer,
Right.
and then the function returns, and asynchronously the Wi-Fi hardware ends up transmitting that, at whatever speed it's set up as. So it may be completely unrelated to what your transmit speed is.
Okay.
I'm just
Interesting.
guessing. I don't know.
Yep. Anyway, seemed to work okay, and was, pretty convenient to use it like that. So
Cool widget, Ray.
yep. Anyway, that's all I had.
Thanks for sharing. Let's see, John, you were up next.
Yeah. So as anybody who's on Discord probably realizes, I've been working on a new funky little robot. I saw a video that Adam Savage did on his Tested YouTube channel a week or so ago, and he designed this cute little Star Wars droid robot. He didn't design a robot; he designed a prop. To be clear, just a 3D printed plastic thing that looks like a robot. It's very cute, and it kind of inspired me. And it's like, that would be a cool thing to turn into a robot. So I've been, let me grab my window here. So this is sort of the second revision of this robot that I'm designing. It's sort of similar to his in that, it's got the same sort of basic swept-back body shape like that, with a little sort of jet engine thing here, and the wheels at a kind of a funky angle. This one is, as I said, this one is basically going to be a robot. If you look at the inside, I've got, a battery. The IMU is going to be mounted here. The microcontroller, which is an ESP32S3, is going to be here. The motor driver's down here. There's let me find the other side here. There's a voltage regulator here. This big orange thing is the battery. It's an 1100 milliamp hour 3S LiPo. And there's a power switch at the very back that goes here. So one of the neat things, I've modeled this in Onshape like I model everything. Onshape has this interesting capability. Oh yeah, and the other thing this has is a couple of really tiny micro servos to actuate the suspension. And so one of the things I want to be able to do is be able to test the range of motion of this thing. And Onshape has these things called assemblies that you can set up, and you basically import the parts that you modeled, and you can set up relationships. They basically, you specify a mate on 2 different parts, and it's sort of like a pivot point in this case, because I'm using what are called revolute mates, which basically just rotate. And so this whole thing can, it basically constrains itself to move all of the parts that are connected with these revolute mates, and including like the servo arm here attached to the servo is also done with that. And that one I've actually restricted the motion of it to, in this case, if we look at this particular one, it's minus 15 degrees this way. So this is basically, if I just turn this off here, so this is basically 0 right here. If I'm looking at this from the front, so straight up is 0. this is minus 15 degrees, and this is 55 degrees on this side. And you can see it's a little bit more than 45 degrees. So that basically shows me how this thing will move when I've got it running. And then I have, I imported one of the side panels here so that I can look at the clearance. You know, and you can see there's a little tiny bit of intersection there, but I'll probably just make this a little bit rounder. And over here on this side, when I'm all the way down, this arm, I actually beveled this part here so that the arm can go down a little bit further and make the suspension go down, which will basically raise up the body when you do that. So anyway, that's one of the neat features of some of these advanced modelers. Fusion 360 does the same thing. You can set up assemblies like this and with constraints, and SolidWorks, of course, which is kind of what OnShape is based on. So anyway, I've been sorry.
The wheel.
What's that?
What size is the wheel?
So this wheel is 90 millimeters in diameter. So it's a little under 4 inches. So for instance, here, let me go back here and stop sharing my screen. And if you look at my monitor, so this is half of a wheel. This is printed in TPU, so it's flexible. So I'm just in the process of printing the wheels now. Just printed this morning. But I've got a lot of the other parts, you know, already printed, with how these things are going to go together, you know, the side panels and the front piece. And designing a robot like this is always a bit of a jigsaw puzzle when you're designing it completely 3D printed, because you have to do the whole thing in CAD and then, you know, print it out. So this is the main part. And for instance, this is a board from Unexpected Maker. It's called a Tiny S3. So this is an ESP32 S3. You can kind of see it there. It's got 8 megabytes of PS RAM and 8 megabytes of flash. And I run MicroPython and we have access to that. So it basically is going to sit in, I've got a little slot there that it sits in, and you can actually see from underneath there, there's little, you can see the pins. There's a couple slots where it's mounted that are holes. So that board goes there. The motor driver, there's another little indent down in the bottom here that the motor driver sits in. The 9-axis IMU, I'm using the Adafruit. Once again, the Adafruit, this is the BNO 085, and it goes on this thing just like that. So it's sitting at kind of a, you know, 90 degrees. Normally you mount an IMU like this, but it's a 9-axis IMU, so it really doesn't matter which way you mount it. And then on this side, I have one of these little Palalu. This is a 5-volt, 5-amp switching regulator. So it's going to mount basically right on this side like that. And then I've got 3 of these little holes here. There's one in the front, and each of the side panels has one. And those, I'm mounting one of these, which are the little time of flight LiDAR sensors. So I'll have 3 of those, one facing forwards and one, you know, each facing left and right. And then I've got a little, if you look on the side of the model here, I've got, there's kind of a slot. You can sort of see it there, basically from between my fingers. And I have these little NeoPixel, very small NeoPixel things, and they're gonna basically sit inside that slot like that. And I have to solder a couple of them together for each side. but then I can make all kinds of glowy light patterns and stuff. And of course, this is, you know, it's an ESP32, so I can use my URC to get telemetry and configure it and all that sort of stuff.
Very cool. Any plans for an eye? That seemed to figure very bigly into Adam's
Yeah.
visual
So-
concept.
So next rev,
Sure.
because I'll want to like something like a Raspberry Pi Zero if I'm going to put a camera in it. But the thing that I was thinking would be really cool would be to build one of these with about a 6-inch wheel, and then I could use a brushless motor like just like one of these. This is a big, I think it's 92. It's almost 4 inches in diameter, 90 millimeters. So this is one of these big, powerful brushless motors. And so basically use that as a hub motor, and then, you know, if the body's that much bigger, then I can put a Raspberry Pi in it. I could put an Oak D light, camera, whatever, you know, all kinds of different things. So that'd be kind of neat. But that's a much later project. This is just a neat little thing with a simple, you know, ESP32 that I can program in MicroPython. And, you know, it's a balancing robot, so it has to, you know, it's a 2-wheeled robot, so it has to balance itself. And we'll see how it works. Oh yeah, the other cool thing about this one is the wheels actually have the motor built in. So I have, this is a similar motor to what I'm using, except the one that I'm using has a right angle gearbox, but this basically fits inside a slot that I've got in the wheel here. And then there's a very large gear here. I can probably show you this easier on the CAD package. I'll go over to where I developed the wheel here. So the idea here, this is the we'll just get rid of the spur gear here for a second. So this is the right angle motor, or the motor with the right angle gearbox with the shaft coming out like this, and then a spur gear that's the motor's driving, which then drives the wheel itself. And this part here, whoops, that's not what I wanted to do. I wanted to do this. This part is fixed to the body, and there's a very large one of those big ball bearings that's like, you know, 3 inches in diameter kind of thing, or two inches in diameter, that's inside here in between the wheel and the rim, which is the part that has the gear that actually rotates with the tire. So there's a big bearing that you can just sort of see the bearing right there.
Wow.
I like the whole thing, and you can see it in there. So yeah, so this basically drives it on each side, and these things come, the gear motors that I bought come with encoders, so I'll be able to do accurate distance and straight line runs and that sort of thing with it.
There's an encoder built into that tiny thing.
Yeah, well, this is this
Share
motor.
the links, please.
Well, I ordered this one off of Ali,
Yeah.
the one that I'm getting, but you can get them the ones with the straight shaft from Palalu. But yeah, I mean the link for this. Let me stop sharing here, and I'll pop the link into the chat. Copy link. So that's the motor that I'm using. I'm actually getting the dual shaft one, even though I really only want the single shaft. But if you look at the single shaft, the encoder comes out from the opposite side of the shaft, and I don't want that. I want the encoder coming out on the same side as the shaft. So I'm going to get the double. I ordered the double shaft ones, and I'll just cut one of the shafts off with my Dremel.
You sure you aren't a mechanical engineer, not a software engineer, John?
I've been doing this stuff for a long, long time.
Well, that's really cool. How do you have any techniques you're using for getting it so it's going to be reasonably balanced when you assemble it all?
Well, once again, let me this guy here, sorry. So if you look at it, right now the battery is kind of a little bit on the back side, and the microcontrollers and stuff, which aren't very heavy, is all in the front. So I may have to actually add some weight to the front. So one of the things I'm considering, I have I can just use a brass bar, but I have this right here. Sure, I looked at this ready beforehand, but I don't know where it is. Oh, here it is. So I have, if you look at my screen here, so this is like this is a 1/2 inch diameter brass rod, solid, very heavy. I also have a 3/8 inch diameter tungsten rod, which I can cut with great difficulty. Tungsten is actually quite a bit heavier than brass. It's actually heavier than lead in terms of density. It's not as heavy as gold, but it's heavier than lead. It's why the military uses it in their, the normal armor-piercing rounds that aren't depleted uranium. But anyway, it's an interesting weight. I might just use brass though, but the idea is that once I figure out exactly what I need, I can add a piece of weight up at the top, because of course with a balancing robot, you want all the weight to be at the top. So I'll add a piece of brass or tungsten or whatever up near the top to offset the weight to make it sit properly. And of course, because I'm 3D printing these things, I can just print a bracket right into the part that the piece of metal just slides into.
Cool. So it's like, see how it turns out and then adjust.
Basically, yeah, that's kind of how I build robots. I'm not a big believer. I understand people like to do all kinds of mechanical fluid stuff, whatever, and density calculations and whatever, and I just don't care that much. I'll build it, and if I need to add a little weight to the back or to the front, then I'll add a little weight to the back or the front. And it's not.
And when you said Adam Savage's model was just a prop, it wasn't a robot, does that mean that it didn't even move at all? It was just.
Well, he had suspension. Like there were springs in it, so that the suspension was articulated. So you could play with it like a dinky car and bounce up and down a little bit and stuff. But it was literally just pieces of 3D printed plastic, the whole thing, and some screws.
And it doesn't balance.
No, it doesn't balance at all. It's very back heavy.
So you'd like use a fishing rod with a piece of nylon that the camera wouldn't see, like holding it up vertically, and you'd like maybe fish the rod up and down to make it move, or
something. I don't know. It's just a toy to sit on a shelf. It's something that he designed, and it's a brilliant design. I love the design. Unfortunately, his design is not really big enough. The center part of it, I mean, if I wanted to spend a lot of time and a bunch more money and build custom PCBs and all that sort of stuff, I could have built one that was exactly the same size. But I'm not really big on building replicas of stuff, either movie replicas or whatever. I don't like building stuff that other people design exactly. You know, lots of people build R2D2s and BB-8s and things like that. And I doesn't, you know, they're impressive, but it's not. I prefer to design things myself. And sometimes what I do, I design from scratch, and sometimes I get inspired from something that I see, and I design something that's similar, which is what I've done here.
Very cool.
Yeah. So anyway, that's what I've been playing with, you know, plus getting Roz ready for Saturday. We'll see how it does.
May the best robot win.
Yeah.
Excellent. Thank you, John. Pat, you had a question.
I did. I have a couple questions. So for the Four Corners competition, does the length and width have to be symmetrical on the course? And I guess I could share the reason I'm asking.
If you guys want to fit your space better, you know, it's a little more difficult to program. You just have to program the different sides, you know. But
Trapezoid.
you know, if you need so let's see what I'm looking at is it looks like it's 14 and 8. It's 22 feet long and 10 feet. Yeah, so
Yeah, it's about 10.5 by 24 roughly, the area.
Yeah, well, you got to have space for your robot too.
Exactly. So I'm wondering, is it possible to narrow the width? You know, we can go long, but to narrow the width for the 10.5 feet that we have to allow for a robot path.
Mm-hmm.
Are you trying to match the perimeter
Why don't
length?
you do this, guys? Let's see. If we were sitting at 12, that'd be 48. If you were at 8, that'd be 16, and so that would leave. Oh God, but come on, Doug. Mine's a horrible thing to lose, guys. Let's see. Minus 16 would be 32 divided by 2. Okay, so why don't you make it 8 by 16?
So if I make that 8 by 16, I don't think my robot's going to fit through there.
Well, you got 10 feet, right? Oh, I see what you're saying. Ooh.
So my robot is, let's say, almost 16 inches wide.
Well, then go 6. Go 6.
So is that an issue if we went 16 by 6 or something like that?
Yeah.
Or 16,
Well,
16
why don't
by
you go, if you can, what would you could you do 20 by 6?
Hey, guys, Pat, you can go outside those ledge sections. They just hold up the outer edge of the carport, and they have concrete and grass on the other side. So you can go
Okay.
outside of those.
I'm a little confused.
Yeah, me too.
But anyway, hey, listen, just Pat,
Yeah.
you know, make it as big as you can. Okay.
Okay, well, we'll
Y'all-
confirm with you
all
before
of
we
you
do
guys,
that.
all of you guys got to agree ahead of time, though, so that, you know, if you're running in four squares, nobody wants any surprises when they get there, because there's nothing worse than programming on the day of the competition. So whatever you guys decide on, make sure all of you know about it and agree to it.
Right. So,
Are
so
you trying to
Doug,
match perimeter run length with what's happening in
Yeah.
Dallas? So that from a timing comparison, you can it's similar.
so what's
Yeah,
the,
so perimeter run length is the one thing that I would try to match.
yeah. So what's
I
the
don't think
perimeter
that-
in Dallas? It's 48 feet.
You know, realistically, when you run these contests, there's a lot more time involved in the getting ready and the setting up and the getting ready to start and the finishing and measuring where it ended up than there is in the actual runtime around the course. So I don't think you need to be worried about trying to match runtime to try and achieve the same cadence as we're doing in Dallas. I don't think that'll be an issue. I think.
Yeah, well, once you have the course set up, and Now, let's kind of go over a little bit of it. For four corners, generally we take a spot on your robot. You pick the spot on your robot, okay? And so it's got to be on the outside edge, guys. It can't be the center of the robot. It has to be something where a guy can drop a pencil along the edge of your robot and make a mark.
Yeah, front edge of the robot or something like that.
Yeah, around on the edges. Usually we do the center or the front.
Yep.
But okay. And so you make a mark on the ground, usually on blue tape. All right.
Okay.
And if you then you make your run, take another piece of blue tape and make a dot on that one. And then the distance between those two pieces of blue tape is your distance.
Okay.
And I believe the rules say that if you're within, I don't remember if it's a quarter of an inch, you're just considered perfect. And the reason for that is you don't want somebody going and say, well, I'll do it in metric. I'm 7.5 millimeters, where the other guy says, no, I'm 7.4. You know, we're just going to say, well, if you get within 6 millimeters, then you're good. Then you're going into time. If you get guys that both have 6 millimeter, you're doing time.
Okay. The other question I had is the start location on the course.
No, you can direction and starting point, and there is a smart way. Otherwise, if you start in a corner, you're going to end up having to do an extra 90. You can
exactly. So I started along halfway down the long edge when I did my last course,
and that's perfect, Pat. That's a good idea. And like I say, usually your robot will run better one direction than the other. I mean, in truth, you're supposed to tune that out, but there comes a point where even tuned out, one way is going to be slightly better than the other way. So you pick the direction you want it to run. And you guys are going to probably not being used to this course because it's going to just be set up right there, and you never practiced on it. So unless you do it right before the runs, and so you might end up putting a little offset into your position or something at the end.
Hey, Doug, you said that time, if multiple robots achieve a perfect score, time distinguishes between them, but that's not in the rules as far as I can see.
Yeah, I believe it does. I believe it says that if there's a tie, then speed. I'm pretty sure.
I don't think so, because let me just share that. So here it says, since it's hard, here's the bit you were talking about, hard to determine accurately distance less than a quarter inch. Robot scores less than a quarter inch will be considered to have perfect score. Where multiple robots have perfect scores, they'll share the first place in the competition. Where there are multiple.
I guess we said it that way, this one. That's different from every other contest. Dave Anderson must have got to me.
Okay, well, I linked in directly from here, so
that's fine. Okay, so if you're within a quarter inch, you share the first class. Well, how we'll do that though is not quite that way. What'll happen is you'll, like, if let's say two of you did it, you would take the first and second prize and split it in half. I think that's, well, I don't know. What do you think, Paul?
Yeah, that seems reasonable.
If you guys do two, if you two of you go and give a perfect score, you get $50 a pop, but the next person doesn't get second place, he gets third place.
Yeah, that's a normal way. Yeah.
Okay. So
I'll be happy if the robot finishes the course.
Right. Oh, and though it may not be in all of the rule sets yet, but our intent is to require a person to make some goal so that they at least don't just put a robot on the floor and say they're third prize because there's three of you. So you're going to have, you should at least get around one corner. I don't know. Is that in there, Paul? Look at the rules. Is there a, like, you have to do at least move so many feet or something like that? I can't remember. We tried it, like, for example, like 6 cans, you got to, I think you have to score 1 can to place.
I don't see it.
Okay, so we must not have updated those rules, but you know, nobody putting a robot just there not running.
So
to
no
say
bricks.
you're in
Huh?
place. Okay, so you got to at least go around the corner.
Oh, I thought 6 can had the no brick policy almost
I
since.
thought it. I thought it did. That's what I'm saying. I
Yeah.
thought that we were trying to move them all that way, so that there's like a minimum bar. It's not a high minimum bar. It's not to try to discourage people, but it's trying to keep people from gaming. You know.
So if I had a robot that just runs straight off the course, that still counts?
I guess if it put a can in the goal.
This time, Pat, yes.
Well, I may enter 6 can then.
Well, no.
I don't think I'll fit under the.
I think on 6 can, I think you have to get one. Paul, pull up 6 cans. I think you have to score 1 can to be able to place.
I was just looking
I
for
think that was, at least that's what we were talking about.
Let's see, is this sharing? Yeah. Okay.
You could zoom that in a bit. It's all white space. Gray space.
Is that better?
Yeah.
Yep.
Much.
Wait a minute. This looks like can soccer.
It says 6 can.
Okay. All right. Slide down.
You looking for that 2-word sentence? No bricks.
Scoring.
Last sentence. No place or prize
Yeah,
will be
there it is.
awarded to a
Last
robot
sentence.
doesn't
The
score
last-
less than
yeah.
1 can.
Yeah. Yep.
AKA no bricks.
No bricks. Yeah. So
Okay. Well, good. You put a lot of thought into these rules, Doug, and I'm glad you're here to represent them, to interpret them.
yeah.
It's still fun to find the loopholes.
Yeah, that's Ray and David and have all encouraged me by finding, and Dale Wheat was the worst.
Hey, I had dinner with Dale Wheat about a week ago.
How's he doing?
He's doing great. He's still making his blinky light boards and just having fun.
Yeah.
He's active over in the other makerspace, the lab.
Yeah. You know, they have a really nice policy. I got to admit, I might just join it because it's so cheap.
Yeah.
If
Right.
you're over 65, it's $20.
Yeah, I know. I was thinking the same thing, Doug.
Yeah.
Like, wow. Okay.
So are they in Richardson now? Is that they moved from Plano to Richardson or something?
Yeah, they're down. Richardson tried to revive their downtown area, and one of the things they were trying to do, and so they ended up supporting that makerspace. I don't know. I think they help them with the space, the actual physical building.
I got the impression they might even be funding them for purchase of tools and such.
Yeah.
Yeah, that's kind of weird. I think Richardson had to close a bunch of schools
Yeah.
just because of I don't know if it was lack of funding or the population was maturing and there
Yep.
were less kids around.
Well, I think
Really?
it's the, you know, that's pretty typical. And even Plano is starting to go through that same cycle,
Mm,
Really?
where they're closing schools because there's just not as many kids in the neighborhood. You know, and I can see my own subdivision, you know, when we first moved here, there was kids all over the place. And now there's, you know, I mean, the bus still comes through, but it's not that many kids.
it's
They're also moving
transitioning
more
from
to
the
charters and privates.
Yeah.
Okay, so did we answer your question? Was that all that you had, Pat?
Yes, so that's all I had. Thank you very much.
Yeah. So basically, Pat, make it work. Do what you guys need to do.
Okay.
yeah,
well,
I don't know where a friend of mine got that expression from, but he used to call that the neighborhoods going from the newlywed to the nearly dead.
Yeah.
I don't think I like that so much.
Nah, me neither.
Yeah.
I'm towards the second end.
yeah, it was probably funny 10 years ago, but not now.
Yeah, now, ooh. Hit a nerve there, I guess.
Yeah.
Okay. So we'll if anyone else has anything they want to jump in with, feel welcome. Otherwise, we'll declare open mic.
Okay, I put something in the chat. Just want to make sure everybody knows it. Is that Palulu's Memorial Day sale is ending tonight, and it's a 24% sale, so it's pretty good. You know, I said I wasn't going to buy anything this year, but I ended up. Mike Williamson, since 8x8 array lidars were so tempting that at 24% off each, I went ahead and bought a couple. So we'll see how that goes.
Cool.
Yeah, I wish that thing had a wider angle. It seems kind of narrow.
Well, one of them is 63 degrees and one of them's 90, depending on which one, the two newest ones.
Oh,
So, you know, he's using, I think, the 63-degree one because he's got three.
yeah, but that's a diagonal measure too, isn't it? The 63.
I think you're right.
He
Yeah.
might be, probably. But he says he covers 100. Well, he might be using the 90 then. And he's saying he's covering 180 degrees with three of them.
Well, that would be 60 each.
But he's got some gaps between them. And I think he did say that was 60 degrees diagonally. So, and he thought it was going to be horizontally.
Horizontal,
So three would give him 180 degrees, but actually he's got 180 degrees, but there are some gaps between each pair.
I thought he told me he's doing about 120 degrees at at last Saturday's thing. Maybe I'm wrong. I don't know.
Yeah. Well, I mean, if you drew the kind of got the feeling for it, you know, I would prefer it to be there's always since the sensors are flat, you know, you're approximating a half circle with three segments. So at they're all going to have at the edges of one sensor and the other, there's going to be a wide spacing unless you angle them to cover it. You know, so anyway, I don't know. It's still, sounded like a fun project to try what he was doing.
Yeah.
Which part was he using?
There's two parts and one of them is pretty new and I have to go to the polo loop. Wait a minute here. I can probably do that. See.
It's using the 8x8 sensor, but I don't know which specific one.
Yeah.
Okay, I think one of them is the VL53 L5CX. Right there.
Yeah.
I don't know I didn't know there was a wider angle one.
Okay, I think, did you say he was using the L7CX? I think that's the one he's using.
L7CX. Okay.
And the new
I
one is,
posted a link to
well,
the page.
there's a new one, an L8CX. That's the ones I went ahead and got. It's got a little more distance and supposedly a little more light tolerance, ambient light conditions tolerance. So I figured that I'd get that one.
You're saying L8, not H, right?
Okay, there's two that you can look at. One is a VL53L7CX, and then there's one that's a L8CX. I think Mike is using the L7CX.
Okay.
And I went ahead and got L8s because they're supposed to have some small improvements in ambient light and whatnot.
Okay. Yeah, actually the one I was showing you was SparkFun.
Okay.
Yeah. VL.
And I think, oh, and another thing, the L8CX also works with SPI. So you're not limited to I2C. So you know what? I think he might be using the L8 because I remember him saying that he could have used SPI, but he decided to use I2C. So he might be using the L8CX.
Cool. I didn't see the field of view listed on the Polulu site for
No, I don't see it.
Yes.
One of them says 90-degree diagonal, and the other one is 65-degree diagonal.
Oh,
I posted a web link comparing all the different ones, and you can see the 90 versus 65.
Yeah. But if you guys are looking at getting some Pololu motors, now it's probably a good time. Get yourself a set. They're not cheap, but you know, that's.
so you got the 65-degree diagonal one, Doug, but you got several. So are you gonna stack them around?
I'm going to try and I'm going to see if Mike can get me started on trying to do something very similar to what he did. Yeah, I'm really curious of what these things can do in the outdoor world. Because if they can do something on the outdoors, that'd be very cool.
Yep. So you're not going for the 90-degree one, this L7?
No, because I was thinking ultimately of going outdoors, so I want more light tolerance.
Oh, okay, yeah.
Yeah, so that's why I went with the one that supposedly got the most light tolerance.
Yeah.
But you know, they did mention a number, and it wasn't Texas bright sun, but it might be November sun.
Maybe you can put a hat on it. You know.
Yeah, yeah.
So
Cool.
Didn't even
Well,
know
I tell you what, getting my little crawly robot has been a pain in the butt.
Oh, how are you doing with that, Doug?
I'm not making a lot of progress. I've been fighting the IMU, and I think I've tracked it down. I think it's the problem. It has to do with I need some adjustments to my pull-up resistors. I hope either that or I'm just severely unlucky because I have an old BNO 055 pre stemma, you know what I'm talking about, the one of their first ones. And I had two that I opened the package on they're just the new ones. The new ones, neither one of them showed up. And I said, oh crap, do I have a wiring area that just burned out two sensors? Well, in for a dime and in for a dollar. So I stuck the old one in and it worked. So I think it's some sensitivity that I'm not looking at. I did find one mistake. I did not realize that Adafruit put level shifters in their SDA and SCL clock. So I put external level shifters in my circuit. And so I was taking the volt from 5 volts down to 3.3 volts externally. And then I was hitting the internal level shifter, which was trying to take 3.3 to 3.3. And I don't know if that might not have worked very well. Okay. So I jumpered out the external level shifters, but it didn't change the situation. And I did read somewhere where they were talking about that as they're built, they have 10K pull-up resistors, and they say that you should take the SDA line and put about a 3K resistor on it so that it'll be a lot faster than the clock line. And they're hoping that that'll clear it up. But I haven't actually soldered them on because I'm going to have to solder that onto the module.
Doug, I thought you said that on Saturday you're having problems with the processor crashing all the time or something.
No. Okay. I'm using an old Nano, the original, or that's not what is it called? Atmel Nano, a 328 basically. And it turns out that because I was trying to do this quickly, I was using the Arduino IDE instead of Visual Code. So anyway, it turns out they have a setting in there. If you go down to the processor where they say 320, 328, old 328, no, it's 328 old bootloader. And I wasn't realizing I had to use the 328 old bootloader selection. So without picking that, I wasn't getting nothing. And that was really frustrating because I couldn't even make the dang Arduino environment work, but figured that out. And so got through that. But while I've been testing out the circuit board and everything, I did realize that the original hexapod battery source of two 18650s and in series is not a long life situation when this thing is running around. Because when you got all 12 of those servos popping and popping, you can easily pull 3 amps out of there.
Oh, wow.
Yeah. So even though they're all the little micro ones, but anyway, that was a little bit of I didn't realize they was pulling that much current.
It's good for one run. Then change the battery.
Well, I think they're going to be 1-run batteries, right? So that's something I have to plan for too. If I were doing it over again and had more time instead of like 48 hours, no, I think I still got 72 hours. Do we have 72 hours? 3 days? Yeah, we got I think we got 72 hours.
Wednesday, Thursday, Friday. Yep.
So, it's not really crunch time yet, but
Getting pretty
I
close.
have infinite time right now.
but anyway, so we'll see. Paul might just win with his little pony that goes down to the end and falls over. We'll see.
Hey,
You mean-
be polite to Pie Dog.
Yeah.
Well, I struggled because I put that HMC 6343 magnetometer on PyDog, and well, actually, I didn't even mount it to PyDog. I was just spinning it around on the table at the practice last Saturday, and I was seeing it go 0, then it'd jump up to like nearly 180, then jump to 360, then it'd go back down to 0, and I was seeing it go clock around 0 to 360 more than once.
Yeah.
And I rotated the sensor once. So I was like, what the heck is going on with this thing? So I haven't looked at it anymore, but I do not have an IMU at this point.
But what
Or-
about the one that's on PyDog?
It doesn't have a magnetometer. It just
You
has
don't need
a
it.
gyro, and
That's all you
and it's a-
need. That's all you need, Paul. It's the
but
gyro.
it's
You're
a
going
sucky
straight.
gyro, Doug, because all it gives you is rate of turn. It doesn't do the integration for you.
Well, you can. Okay, so it's a rate gyro. Okay. Well,
Yeah.
you
Yeah,
can.
most of them are, aren't they?
We'll use
you
that to
You
go
can
straight.
do that yourself. And go ahead and figure out your heading and just adjust your heads. Go back to your 0 heading.
Yeah.
That's what I plan to do.
Say
Well,
that again?
on the 350, on the 055, you'll get a heading.
Yeah.
With the gyro mode, you'll still get a heading. So that
Don't
makes
you
so.
integrate, and that gives you your heading?
Huh?
I thought you just had to integrate it since it was a rate gyro.
Well, apparently the one that's on PyDog must be a rate one.
Yeah, and I guess you could integrate it, but it seemed pretty noisy to me. It's just looking at the values coming out, and they were like jumping all around, and I was like, oh, and then what rate do you need to integrate it? With something like one of those MEM sensors, you'd typically integrate at a millisecond or that sort of rate, right?
Yeah.
And I don't think the Raspberry Pi is going to run a millisecond consistent kind of, that's the sort of job that you give to an ESP32 or an Arduino or something like that.
Well, what I would have said, thinking about this, you might have, I don't know, I think 72 hours might be pushing it, but if you go out on Amazon and you look at the WT601, it has what do you call it? A Kalman filter in that one. And I think you could use that. And that's just, it would fit probably, the screw holes would probably fit.
WT601?
I think so. WS.
WS601. Like from who? Because I'm getting a bunch of spurious results.
Okay, give me a second. I have to find them.
You can just order the Adafruit BNO 085.
Yeah.
But
not
that
cool.
one you won't get back by Saturday, I don't think.
I order mine from DigiKey. I get it the next day.
Yeah, that's lucky. I guess you could possibly do that from Mauser here, but give me a second, Paul.
Yeah. Actually, Amazon has BNO 085 for $20, free delivery tomorrow. So I could do that, I guess.
Yep.
Which one is it?
Is that Adafruit's product?
Okay. I gave you, it wasn't WT, it was WIT. Okay.
No, it looks like it's
Oh,
a Chinese.
the part is called WT61. And it's by WIT Motion or WIT Motion.
Arduino accelerometer and tilt sensor. Gyro angle with Kalman filter. Oh, that sounds pretty good. Prime 1 day delivery. What's its interface like? Is it I2C?
Which one are you looking at?
The WT61.
I like the 085. It has a couple different modes you can use, and the one that I use normally is what's called RVC mode. And it basically, it's a UART that you plug in to, so it's a 1-pin connector, and it runs internally at 100 hertz and dumps a packet containing pitch, roll, and yaw plus the 3 accelerometer values, all pre-filtered at 100 hertz without you having to do anything.
That sounds good. But
Yeah.
What was the
by
intent there with
Saturday?
the acceleration? Was it that you could integrate it and get distance, or
No,
no?
no.
Do you know
No.
what the
These
purpose-
things are nowhere near accurate enough to be able to do that. There aren't. You can't buy a hobby level gyro or IMU that'll do that. You know, you're talking $20,000 IMUs that do that kind of thing.
Ooh. So why provide it then?
Well, because it
So you can
allows
tell
you
which
to
way is
measure.
down.
Yeah, basically you measure gravity.
And that's helpful because if you're using the magnetometer and as part of the equation, it matters, because the Earth's magnetic field comes in at a weird angle, so you have to know that to be
Well,
able to.
the thing is that if you're using something like a 085, and I don't know what this WIT thing does, but the 085 gives you a fully stabilized filtered pitch, roll, and yaw, which are the important things that you need. You can completely ignore the accelerometer values if you want, which is what I do. All you really need are pitch, roll, and yaw, and really for most of what you're doing, all you need is yaw, because it's
Right.
headed. So I've got a slightly different 9-axis IMU in Roz's head, and that's all I use is yaw. It's basically a stabilized compass.
Yeah. So that was my trial and tribulation on Saturday with the compass. But I was really excited. We got well, I guess there's been a couple of things happen working with Kareem. I recorded a new version of the Docker Ross on Docker workshop, and I feel like it was a much cleaner take than the first version. And so I actually installed Ross on Docker on PyDoc, and haven't done anything with it at this point. But Kareem's playing with it, I think, right, Kareem?
You bet. Really appreciate the time on that workshop. I'm deep in a rabbit hole of like how many different kinds of customizations I want to do now. It's like I'm getting task saturated by the plethora of options between different virtual displays and remote debugging and all sorts of things. So yeah, I'm not working on the robot at all right now. I'm just trying to figure out my perfect environment with Docker.
So we've got a another session scheduled at 7:30 tomorrow. And did you have a sense of whether you want to finish off going in depth into the Docker scripts, or do ROS CLIs and GUIs, or both?
I might be past that point for Docker, so I'd probably personally be happy to go back to ROS 2.
Okay. So I might post that on the, I guess, on the Discord.
Were we saying 7:30
Yeah.
p.m.?
Yeah.
Okay.
Does that work for you?
Yeah, I think so. I think that'll work.
If it doesn't, let me know.
Okay.
I feel much better after listening to the conversations about readiness for this coming weekend. I thought I was running up against the wire and finally completed today. Clearly, I'm way ahead of the curve.
Well, Tom, I was doing all kinds of hackery on Saturday to try and at least see if I could get it to land within the two boxes, with the box on the way out and the box on the way back. Like, because when it was walking forward, it tended to veer left, but it walked backwards straight. So I was giving it a little, giving it like 10 paces forwards, then turn right for a step for a pace, and then another 10 paces forwards, turn right again, trying to, extreme hackery.
Well, I have dead reckoning odometry sort of on this stepper motor based thing, which will repeatedly arrive at a destination 14 feet away within 1 or 2 centimeters. However, turning is a much, much more difficult problem because I don't have the resolution of control over turning these stepper motors. So I'm lucky if I can get it to turn 180 degrees within 2 or 3 degrees. So I'm not going to make that 7th point for sure.
Why didn't you just drive backwards back to the start?
I had given that some thought, actually. That was plan B. But I thought, no, I want to make this turn in place logic work. I did want to bring up a software issue that I came up with today and had to solve. Now, admittedly, I'm using 8-bit Arduinos, and I'm still using the Arduino IDE. But I use LCDs, and for formatting, I find the sprintf function to be a handy way to configure stuff, especially to drive the 16-character fields in LCDs. But I discovered that when you provide the formatting string for an sprintf function, which is then has to match the list of variables that you feed into those formatting components, if you don't make the formatting field big enough, that is, having enough characters to accommodate the size of the number that, for example, is in an integer, not only do you not see it on the screen, but it then zeroes out the contents of your variables. It drove me crazy trying to solve that today. Really a bug.
Gotta love C.
Oh, it blew me away. So what happened was my testing worked great until I extended the range that I was attempting to test over, and the range got the values I'm using, which are some counters and states for a state machine, being displayed on the display for easy testing. When I extended the range of the testing to the point where I got into that 3rd digit, when I'd only defined 2 on the display, and my variables go to 0, and my logic fails. Very, very frustrating. So, it's just a fluke I found it, I think. You get to the point where you're desperate and you're changing everything in the code, starting to drop out all kinds of code to see if the problem will go away or come back. Anyway, piece of advice for whatever it's worth. That's the sprintf formatting function.
Yep.
Just finished putting this thing more or less together. So it's got most of the electronics, although not any wires or anything inside, and the battery seems to feel pretty decent. These are just sort of hanging here because I've only got one of the servos. I've ordered the second one from Ali, but yeah, I'm pretty happy with this.
Cool. That is a very cool looking robot.
Yeah, it'll be. I mean, these are just the wheels. The tires are actually quite a bit bigger, so it looks a lot more proportionate once it's actually got the tires on it, kind of thing. But I'm also waiting for the bearings to show up, which I ordered from someplace in the US. But yeah, I'm pretty happy with this. So this is my first balancing robot. It's not bad. It actually balances it. If I tilt it about that far right now, it balances pretty evenly. So
Wow.
I'm not going to need very much weight in the front to offset the battery.
Yeah, Tanner's used to sell them many moons ago. It was like a motor with a plastic wheel, and it had like an O-ring for a tire, and I don't know, wheel was maybe 3 inches or maybe a little bit bigger in diameter. I don't know if you ever remember seeing those. But if you used a piece of make block to attach to the bottom of that housing, it pretty much balanced itself because of the weight distribution within that gearbox and the motor. So it was like, yeah, I made a self-balancing robot and wasn't even trying to, It's like, yeah.
Yeah, I may end up changing the tire design. I don't know if I'm printing this in 2 halves. It's basically like almost like an inner tube, so it's completely round. So I'm printing it in 2 halves. I'm going to try and glue them together using some like industrial solvent or something. But what I may end up doing is just doing a mostly ABS wheel and just having a little strip around the the center that is TPU. So I'll have to see.
So,
Oh, go ahead.
John, you're saying that the wheel is 3 parts?
Oh, it's
2
more
sides?
than that. I mean, this is the tire, and then this is the rim. You can see it's sort of shaped like that. So the tire, the idea is the tire goes on this part, and then this part, there's a bearing that fits in this space here,
Yeah.
and then that slides onto this surface here. The inside of the bearing is on this surface, and the outside of the bearing is on this surface.
Yeah.
So are you making what's, I think they refer to it as semi-pneumatic? It's, it's got air in the center, but it's not pressurized.
No,
Is that your,
no,
is that
these
your
are, this is solid. I mean, it's TPU that I'm 3D printed, so it's not completely solid. If I cut it open, it would have the same pattern that any 3D printed part would have.
Oh, okay. Yeah.
So it's reasonably flexible. But I don't know. I'm not 100% sure I'm going to be able to print. Well, I'm not 100% sure I'm going to be able to glue the 2 parts together perfectly. I may have to make a jig to glue it. So we'll have to see.
TPU does not glue well, in my experience. It welds pretty well, but are you printing in 2 halves to avoid support?
Well, yes and no. I mean, I'm printing in 2/2 because I get a much better, cleaner surface with TPU on the top half than on the bottom half. So this is printed, like the bottom half is printed directly on my print bed, and I get a reasonably smooth surface. When I print in TPU with that kind of overhang, like if I printed it like this, essentially as an entire round part, then it's going to end up, the bottom ends up really messy.
Yeah, it's definitely messier,
Is it
but
the
that's still a
support?
pretty small part.
Yeah. From what I've
Yeah.
read, and I did a little research on this, you can actually use PVC cement to glue TPU. It
Really?
apparently works fairly well.
Huh.
I mean, there's a specific UV solvent you can get that is the best stuff, but a UV activated solvent. But I'm going to try the PVC cement, and I've also heard that E6000, which is one of those industrial glues you get in a tube, that also works on TPU. So I'll try a few different things.
Good to know.
What, Doug? Couldn't understand you. Oh. Oh. Think we lost Doug or something.
Oh. No, I'm over here in the soldering guy.
Yeah.
I'm listening, but not watching so much. Another thing that's kind of cool to know about is these things that they use to repair car bumpers and stuff with, where it's like it's a 3 volt. It's a transformer that steps down 120 to 3 volts.
Oh yeah, millisecond
Yeah,
S or wavy
Yeah, and you put a
pattern.
little thing on it and stick in it. And what you do is you let it get hot, and then you stick it into the plastic. And that's actually works real well with certain plastics. I don't know how it would work with that one though.
Yeah, TPU is kind of icky. I mean, the other option that I have is I can print a mold and just pour silicone as well. And if I can't get the TPU to work, then I'll do something like that. So we'll have to see.
What I was thinking was just to have like 2 sides and a middle part.
Yeah, well, and that is another option, and I can do that either in TPU or molded in silicone.
Yeah.
So do you 3D print your silicon molds?
Yep.
Yeah. Have you done a lot of them? Does it work?
I've done a couple of them. The foot that I did for my walker, my biped walker. Let's see anything over here. I printed.
You'll see. You got to watch those shots. I think I may have seen some plumber's cleavage there.
Oh well. Yeah, it's around somewhere. I'm not sure where it is. It's I 3D printed a mold and poured the silicone in and then screwed it down. I have the spray release stuff and it worked pretty well for making the silicone feet for the robot. So it's a decent way to do it. We'll see. It's very soft. It's silicone. The silicone that I have is fairly soft, so it may end up working better than TPU anyway.
Oh my God, that's one heck of a URL there, Kareem.
Yeah, look at the URL below it. That's the actual one.
Oh, okay. RS Online. Huh.
Oh, out of stock.
90 millimeter bore, 96 outer diameter. That's almost what I need. I need 90 millimeter outside diameter. That 91, no. Yeah, they have a whole bunch of them there. Wow, that's
Huh.
So do you have like a super wide diameter, super narrow bearing that goes inside that wheel?
yeah. So mine is about 60, 65 or 66 inside diameter and 90 outside. I don't know if they make one like that or not. That's really cool though. They seem to have, I didn't realize that they had really big ones like that.
You only have to buy 1,000 of them.
Yeah, that's a problem. Inner diameter 65 millimeters. What do they have? 65 by 90. There we go. No, that's a square one.
What's your inner requirement?
65.
Whoa, that's a fat wheel. Okay.
Yeah. So they have one that's 65. It's not round. It's a different. I mean, it's a seal, not an O-ring. But yeah, I mean, looking at the CAD model, let me see where I originally defined it. It's sketch 2. And yeah, it's 12 millimeter diameter. That the circle that makes up the tire. I mean, I can change it. Obviously, it's I can make it a little bit smaller, a little bit bigger. It just have to change the inner wheel piece that I print as well.
So Doug Dodgen, are you bringing your Pi Dog to Roborama on Saturday?
I don't know. I wasn't planning on it, but this guy, if I can't get him done by tomorrow, then yeah, I might switch over. We'll see.
I
wanted to have something different, you know what I mean? I wanted to see if we could have like different types of robots. But like I said, this isn't working out, and I don't know exactly where the problem is.
As for me, I've been traveling the last 2 weeks, so I haven't had a chance to do anything to it. If I can get it to go forwards and backwards for that amount of distance, I may show up with it.
Okay. Well, more the better.
If you want, I'll give you a leg up and point you to my repo. That's I can check in the latest code that will make it walk forwards and backwards. Or at least we could have like 2 Pi Dogs and see who can aim them best.
Okay. Okay, Paul. Send me the link. Send me the link. I'm not proud.
Yeah, give me the link.
All right,
So we got 3 Pi Dogs?
Send it to both of you. Yeah.
We might have a 3 Pi Dog legged competition.
Will they go side by side, see who's fastest?
Paul, don't give him your best. Give him like the -1. Because otherwise, you may lose.
I'm not like that, Ray.
It's actually kind of funny when I did the very first version of RAWs. Mike Ferguson built. He had one. He built the inverse kinematics, and if you watch the video on my YouTube page where we're competing, his went a lot faster than mine and the other guys because he had a gate that moved 2 legs at the same time, and he only gave us a gate that moved 1 leg at a time. So that was pretty funny.
Yeah, that was a cool video that you shared of Roz competing and his robot competing.
Yeah, that was a long time ago.
Yeah. In a different universe.
Yeah. Yeah, these O-rings are tiny, like, 3 millimeter diameter O-rings.
Yeah, I thought maybe, well, I don't know if you have Harbor Freight up there in Canada or not, but I got a box of O-rings that fit the smaller motors. And
Yeah.
that
Yeah, I
worked out.
mean, I have a box of O-rings too, but none of them this big.
Mm. Yeah, I think the box I have only goes up to like 54 for an ID millimeters.
Yeah.
So 90 is pretty big.
Over my repos.
Maybe I should look at that website. My wife she's trying to find this O-ring that goes on top of the pool filter, and the original one is definitely skinnier than the one that they say is the replacement, and the replacement one is so fat you can't get the lid back down over it. You can't squish it enough, and she's ordered it like a couple times from a couple different places that it's supposed to be the right one, but it comes back as the same one, which is not the right one. So
Okay, there you go, Doug and Doug. I've given all my secrets away.
All right.
I've
all
pasted
Dougs are covered.
the just checked in the hackery from Saturday, and we'll see if any additional hackery or actually real engineering happens between now and Saturday. I've got a lot going on. I'm like leaving for 3 months on Monday, so I won't have much time to work on it. But there you go.
I was expecting to be on vacation all through June the 1st and not even be there, but we came home early. Since you've shared your code, I'll share my idea that I have not yet implemented. I've noticed that the Pi Dog slips sometimes with them skinny little legs. I was planning on putting rubber feet on the end of mine. I don't know if it affects it, but there it is out there for everybody.
Yeah.
Roz has TPU feet, which is essentially the same thing. But I've
So what does the end of the foot
rubber
look like?
nubs that you stick on the end of things, sort of like eraser things.
Yeah. The other thing I had to do in order to make it not slip like that is I have to accelerate gradually. I can't go immediately to full speed. So I increase its speed by like 2 millimeters per second every cycle, and I'm running at a 50 hertz cycle. So, over the span of a second, it gets up, well, a little bit over a second, it gets up to full speed. Which is like 120.
We're getting down to 9 people, and I feel like we're losing energy. So maybe it's time to call it a night.
Sounds good to me. I'm still trying to set up my new phone that took me so long to get, so I had to get here late. Talk to you later.
Okay.
See you guys
Thank you.
on Saturday, hopefully.
All right.
Virtually.
Virtually. Yes. And we'll see how this new recording scheme worked out.
Yeah. Cool. All right. See you guys.
All right. Good night, guys.